Hey everyone, in this video we're going to be going over the computations for permutations and combinations. So last week you had a couple Edpuzzle videos. Those kind of explain the difference between the two of them. Then you had quizzes where you had to choose the difference. So today we're going to get into the computations. So the big thing that's different between permutations and combination is permutations, the order matters. So if it was in this case a track meet, the order that the people finish, first, second, and third matters. Whereas if this would be a combination, the question might be worded differently, and then that you have 7 athletes and the top 3 advance to the next round. So with the combination, the order wouldn't matter. You're just going to take the top 3. Whereas the permutation, the order matters whether they got first, second, and third. So we're going to actually do the computations of these today. So we're going to have a couple of formulas. The first one for permutations, again, where the order matters. So order is important. And another thing to note is that permutations are always a bigger number than combinations. Always bigger than if you were to do a combination. The formula looks like this. Permutations are just P. We do a little n comma r. That equals n with an exclamation mark over n minus r with an exclamation mark. This is the formula. The exclamation mark is called a factorial. You've probably seen that at some point maybe in your life. Factorial. What that means is, if, for example, if I had 5 factorial, that means 5 times 4 times 3 times 2 times 1. So you just multiply by every integer as you subtract 1. If you had 20 factorial, it would be 20 times 19 times 18 times 17, 16, 15, 40, all the way down to 1. So that's what a factorial is. So our formula has these factorials in them. So in this particular problem, if I were to set this up, the n represents the total. The r represents how many you're going to choose. So say the number chosen. So in this problem, we have 7 athletes, and we're going to choose 3 of them because we got a first place, a second place, and a third place. So we write this like this: P7, 3. 7 total athletes, and we're going to choose 3. We would pronounce this 7 choose 3. So then using the formula, this would be 7 factorial, because that's our n, over parentheses 7 minus 3 factorial. So that's how we'd plug it into our formula. And then if we were to actually solve this, your calculator, it turns out, does have this factorial button on it, an exclamation mark. But if you were to actually write this out, this would be 7 times 6 times 5 times 4 times 3 times 2 times 1 over, on the bottom, that would be 7 minus 3. So it would be 4 factorial. So it would be 4 times 3 times 2 times 1. And then what ends up actually happening is these cancel out. So then your answer ends up just actually being 7 times 6 times 5. So that would be 210, would be your answer. So there's 210 ways, which seems like a lot, right? If we have just 7 people, it's 210 different ways they could finish first, second, and third. All right, now your calculator actually has a button that does all of this for you as well. I'm going to show you that and explain to you how to get there. So for a calculator, it's pretty simple. You're going to write it a little bit differently. Your calculator uses the notation NPR instead of P with N comma R. So what you're actually going to do is type in the total first, just on your calculator. So in this case, we had 7 total. So type total first. And then you're going to hit math, And then you're going to go over to PRB. And you'll see NPR there. NPR. So you're going to hit enter on that. And then you're going to type the R value. So I'm going to hit 7 math over to NPR. And then I'm choosing 3. So it looks like this. Sorry, there's a lot of space here. So 7 NPR 3. Enter, and I'll get the same 210. 7 NPR is 210. And we'll go over that a few times. Let's try another one here. So I'm going to keep the formula here. Just to show you. All right, so we have students, Henry, Sarah, and Kylie. They lined up. How many different ways can they stand in line? Okay. So let's think about how many total people there are and how many we're going to choose. So this is going to be P. How many total people? Well, there's 3 of them, right? And how many are going to line up? Well, actually, all 3 of them are, because it doesn't say only 2 are going to stand in line. It says actually how many different ways can they stand in line, meaning they're all going to line up. So this is actually going to be P and then 3, 3. So the way we would read this would be 3 choose 3. If you were to use our formula, this would be 3 factorial over 3 minus 3 factorial, because n and r are the same. Okay, so we'd have 3 times 2 times 1 on top. On the bottom, you actually end up with 0 factorial, right? The good news is 0 factorial is not 0, it's actually 1. So it becomes 3 times 2 times 1, which is 6 over 1, so it'd be 6. So there's 6 different ways these 3 students can line up. Typing this into your calculator, you would want to do 3. So you hit 3 first, then hit math over to PRB, and then hit NPR, and then you just hit 3 again. So 3 NPR 3. Enter, and you actually get 6 as well. It's good to know how to do this both ways. However you choose to do it on your own is up to you, but that is how you do it. And the way that you can think of this is a decent job explaining it here. But so the first person, let's say Henry's choosing Henry first. Henry has 3 spots he can choose from, right? He can be like first, he can be the middle, or he can be last. So Henry chooses his place. Well, then how many does Sarah have left over to choose from? Well, let's say he chooses the front. Well, then she only has 2 left to choose from, so she can choose middle or back. She chooses her place. And then Kylie, well, she only has 1 place to choose from, just whatever's left over. So Henry has 3, Kylie has 2, or sorry, Sarah has 2, Kylie has 1. So you're just multiplying these. This is actually called the fundamental counting principle. You just multiply how many options each of them have. So 3 times 2 times 1. And you get the same thing as if you actually were to use this permutation. That's how it all works. All right, let's go ahead and do one more. I'm going to delete the thing here. All right, so the first thing they always want to do, these are all going to be permutations, so at least the first section you don't have to worry about it. But permutation, and then you want to think how many total they are, 25 total, and then how many are we going to choose? We need a president, a vice president, a treasurer, and a secretary. So we're going to choose 4. So this is 25 choose 4 is how we'd say this. 25 choose 4. So our formula was n factorial, so 25 factorial over 25 minus 4 factorial. Now, if I were to actually write all this out, this would be 25 times 24 times 23 times 22 times 21, all the way down, right, over. The bottom is going to end up being 21 factorial. So that would be 21 times 20 times 19 times 18 times 17. And what you'll see what happens is at the top and the bottom, all of these actually go away because they cancel out with these, because that has 21 all the way down. This has 21 all the way down. So to solve this, all you actually have to do is type in your calculator, would just be 25 times 24 times 23 times 22. No, actually, we're 22 twice there, sorry. And that would be it. So we get 303,600. So that means there's 303,600 ways to choose president, vice president, treasurer, and secretary. That's a lot, right? The other way you can do this, again, with your calculator, is you just do 25, and then you do the NPR. You go math over to PRB. 25, choose 4. It's good to actually do both of these ways just to check your work. 25. Remember, you have to type 25 in first. You go over to math, NPR, and 4, and you get the same number. So 303,600 ways to choose those 4 positions. All right, now let's go on to the next one. And that's going to be combinations. And should I do this real quick? All right, combinations are pretty similar. The big thing to remember with combinations, and just ignore the title, this is all going to be, first set will all be combinations. So combination is order does not matter. So generally in this case, it's just going to be like selecting 5 people or the top 3 finishers, something like that. Okay. So this is going to be selecting sort of a group, but the order of that group is not important. All right. So there's a similar formula. The formula actually for combinations looks very similar. It's just right here. It's combination n, choose r, equals n factorial over r factorial times n minus r factorial. So the only thing that changed is you have this extra little r factorial on the bottom here that you're multiplying by. So that's the only thing that changes. We still read it the same way, like n, n choose r, 40 choose 2, whatever it is. So that's what it looks like. So let's do one by hand first and then show you how to check that on the calculator. It says Mr. Bell's math class consists of 13 sophomores, 6 juniors, 11 seniors. How many different ways can Ms. Bell create a 5-member committee of seniors? Each senior has an equal chance of being selected. All right. So it is important that you notice a little bit of the wording here. It's a 5-member committee, so we're going to choose 5, right? Let's think about how many total, though. We're only going to do seniors. So we had 11 seniors. So we don't want to add them all up for this particular problem because it says just seniors. So we're going to do 11 total, and we're going to choose 5. And it just says a committee. It doesn't say like, vice president, whatever. That's always the hint if it just says committee. Right. So it's going to be 11 factorial over, r is the second number, so 5 factorial times 11 minus 5 factorial. And if we start to write this out, on the top it's going to be 11 times 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1. On the bottom, we got 5 factorial first, so 5 times 4 times 3 times 2 times 1. And then times 11 minus 6 factorial, so that turns into 5 factorial, so that turns into 6 factorial. So then we have times 6 times 5 times 4 times 3 times 2 times 1. So if you write all these out, you'll see we do get cancellations, as we would expect. The 1s cancel, the 2s, 3s, 4s, 5. Oh, 5 twice, whoops. 6 cancels. So those all cancel. We are left with all of this, though. So we'd want to do the top and the bottom separately. On the top, we'd want to do 11 times 10 times 9 times 8 times 7. That gives us 55,440 over 5 times 4 times 3 times 2 times 1 over 120. And then we would need to go ahead and divide. And we get 462. So 462 combinations. Remember, combinations are always going to be smaller as well. If we had done permutations, it actually would have been 54,440. So it would have been 55,440 if the order mattered that we selected them. But since the order doesn't matter, we're just taking the committee of 5. It's only 462. Now we check this the same way. On your calculator, you're going to get to it the same way. You're just going to type it in as 11, and then you're going to go calculator, hit math, over to PRB, down to NCR this time, because we're talking about combinations, NCR. And then we're going to choose 5. So 11, NCR, 5. Just remember, we got to type in the 11 first, then go over to NCR, and then 5 to get this. So 11, NCR, here, 5. Double check, we do get 462. So either way works. If you don't have a graphing calculator, TI-83 or TI-84, you're just going to have to do this by hand or some other alternative. That's how it's done. Let's go ahead and try a couple more real quick. We'll leave that formula up here for right now. And gotta switch the problem type real quick. Another combination. All right, pizza shop has sausage, mushrooms, onions, bacon, and pepperoni. Obviously, when you put these on a pizza, it doesn't matter the order that you put them. I guess if you're really picky, it might, but it doesn't matter the order that they put on the sausage, mushrooms, onions, bacon, and pepperoni. They're just going to put them on. It doesn't matter which one goes first. It's still going to taste relatively the same, right? So how many different ways can a pizza made with 4 toppings? So again, it says nothing about order. That's our hint that it is a permutation. So let's think about what it would be. We've got how many toppings? Total 1, 2, 3, 4, 5 total toppings. It's going to be C5, and we're going to choose 4. It's 4 toppings. We're going to choose 4 of them. So then this would be 5 factorial over 4 factorial times 5 minus 4 factorial. So if we write this out, 5 times 4 times 3 times 2 times 1 on top. In the bottom, we got 4 times 3 times 2 times 1. And then 5 minus 1 is just 1, so it's 1 factorial, just times 1 again. So when we do this, we got 4's cancel, 3's cancel, 2's cancel, 1's cancel. So we end up with just 5 over 1, or just 5. So there's only 5 different ways you could do those toppings. We could, again, check it on our calculator. We would just do 5 NCR 4. Go ahead and do that. And we get 5. So that is it. All right, now our last set of problems, you're going to have to choose between the two. So let's go ahead and do that. Erase everything here. Some of them might be very similar problems. It'll give you a random either combination or permutation. All right, so let's say I start with this one. We got 11 students running a race. How many different arrangements of first, second, and third are possible? It's not going to tell you this current type when you do it on your own. But how are you going to do this? So think about, first of all, whether this is a permutation or combination. This one actually kind of tells you, or it tells you permutation just because I'm in the teacher view of it. But notice it says first, second, and third. So the order is important, right? So you want to first identify it's a permutation. We then have 11 total students, and we're choosing 3 of them. So this would be a P with 11, comma 3. Then it's n factorial, so 11 factorial over n minus r factorial. So it's 11 minus 3 factorial. So if you were to write this out, it'd be 11 times 10 times 9 times 8 times 7 times 6 all the way down On the bottom, it would become 8 factorial because 11 minus 3 is 8. So 8 times 7 times 6 times 5 times dot, 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 all the way down. And what ends up happening, this cancels, this cancels, this cancels. All these cancel. And we're left with just 11 times 10 times 9 on the top. And that becomes our answer. So 990. Again, we could do this on our calculator. 11 and PR, 3, and you will get the same 990. So make sure you are identifying on this last set of problems whether the order is important or not. All right, let's try another one here. This one says the principal would like to assemble a committee of 14 students. So committee is a key word because it doesn't say any specific roles for these committee members. From the 17-member student council, how many different committees can be chosen? So this is a combination. So it's C, 17 total, choosing 14. Another thing to note is that the total N is always bigger than R. You got to have more than or the same. It's always bigger or equal than R. Okay, just gonna say N is always greater than or equal to R. Always got to have the bigger number first. So if we put this into our little formula, we get N factorial, so 17 factorial, over R factorial, so 14, factorial, times 17 minus 14 factorial. That gives us 17 times 16 times 15 times 14 times 13, all the way down, times 12 times 11, whatever. On the bottom, we got 14 times 13 times 12 times 11 times all the way down, times 3 factorial, right? That turns into 3. So 3 times 2 times 1. So what ends up happening, 14 cancels, 13 cancels. So these all cancel with these. And then we're left with 17 times 16 times 15 on top into 3 times 2 times 1 on the bottom. So that's 4080 on top over 6 on the bottom. And that's 680. All right, I think we will stop there. Remember, you can always check these on your calculator. Just pay attention to whether it's permutation or combination, and good luck from there.